Welcome to the Waste Isolation Pilot Plant. I'll be your guide on today's virtual tour. Our tour today should take about 35 minutes and will consist of two parts. In the first part, we'll walk you through the waste handling process from the time waste arrives at the site until it's emplaced permanently in the underground, 2,150 feet below the surface of the desert. In the second part, we'll actually take a tour of the site on the surface and in the underground. This should be an exciting tour we put together for you. We hope you enjoy it. Let's get started. The Waste Isolation Pilot Plant, or WIPP, is located 2,150 feet underground in the remote Chihuahuan Desert, 26 miles southeast of Carlsbad, New Mexico. In the 1950s, scientists determined that deep geological salt beds were the ideal medium for the permanent disposal of transuranic waste. In the 1970s, the Atomic Energy Commission chose Eddy County as the future site for WIPP. WIPP sits in the middle of a 1,000-foot thick salt bed, which runs all the way from southern New Mexico up to Lyons, Kansas, which was the original site chosen for WIPP. Construction began in the 1980s, and WIPP received our first shipment on March 26, 1999, over 20 years ago. WIPP is permitted to receive only defense-generated transuranic waste, which is composed mostly of gloves and rags and tools that were contaminated during the research and development of our nation's nuclear program. True waste, or transuranic waste, is brought to WIPP by truck in specially designed transportation casks called TruPaks. TruPak casks underwent rigorous testing before being certified by the Nuclear Regulatory Commission. They were dropped onto an unyielding surface, onto a steel spike. They were submerged in the equivalent of 50 feet of water, and they were submerged in jet fuel at 1,475 degrees for 30 minutes, and they passed with flying colors. Cask Specialty Trucking is the contractor for the Department of Energy. Cask drivers are highly qualified, experienced drivers who travel 24/7 while transporting true waste to WIPP. While they're on the road, a company called Transcom monitors those shipments in real time from the time they leave the generator site until the time they arrive at WIPP. When a shipment arrives at the WIPP site, the cask truck decouples from the trailer and crews remove the TruPak casks from the trailer. 3 TruPak 2 or half-pack casks fit on a trailer. Now, half-packs hold half the number of drums compared to a TruPak 2, and they're used if the waste in the containers is heavier than normal, say if they have soil. The TruPak casks are brought inside through an airlock system, and they're placed in raised TRU docks, which allow crews access to the top of the 10-foot tall TruPak units. A TruPak 2 can hold 14 55-gallon drums, 10 85-gallon drums, 6 100-gallon drums, 2 standard waste boxes, or 1 10-drum overpack container. The waste handling building, where this contact-handled waste bay is located, is under negative pressure, and it's under HEPA filtration to keep any radiological material from reaching the environment in the unlikely event of a release. Radiological technicians survey the containers as waste handling crews use special tools to remove the 2 lids from the TruPak casks. They pull the containers out of the TruPaks using a special crane, and once the containers are out of the TruPaks, they're tied down on a facility pallet and ready to be taken into the repository, where they will be emplaced forever. When it's time for a pallet of waste to be downloaded, a forklift loads the package onto the conveyance loading car, which sits on rails. The waste hoist is brought to the surface, and then the waste is loaded onto the cage. The conveyance loading car doesn't make the trip into the underground, but as the pallet is loaded onto the cage, the conveyance loading car drops down and comes back out, and the waste sits on two chairs that are in the cage. Personnel and materials can travel on the waste hoist at the same time on different levels, but transuranic waste, or true waste, always travels by itself, and it's never accompanied by people or materials. Once the true waste package has arrived at the waste station in the underground, a waste transporter backs up to the cage, and a hook on the back of the vehicle pulls the facility pallet onto the transporter bed. Spotters are used during the loading process to ensure that the waste is safely loaded onto the transporter. The waste transporter is used to move the true waste from the hoist to the emplacement panel. The operator actually sits sideways in the vehicle as they transport the waste. This allows them improved visibility as they move the vehicle forward and backwards. You think it's hard to drive on the wrong side of the road? Imagine driving facing the sidewalk. Now, because the transporter is diesel powered, sufficient airflow is required to dissipate that exhaust before the crews are even able to operate the vehicle. Due to limited airflow in the underground, waste emplacement takes place during the day shift, and mining takes place during the back shift. So this is kind of a funny story. When designing the waste emplacement process, we didn't want to use a traditional forklift because of the risk that the forks could puncture in the radioactive waste drums. So to solve this, a team was sent to a brewery in Colorado to see the push-pull device that was being used to move beer kegs. WIPP altered the design, but the same concept to push or pull the waste onto a large spatula by clamping a slip sheet at the bottom of the waste package was used. The push-pull device pulls the waste package off of the transporter and then drives it to the waste face, where it pushes the package off onto the disposal room floor. The transition line is the border between the clean area and the contaminated area, or the CA. Inside the CA, crews are required to have special training and wear protective suits and respirators. The transition line is a line set up between the contamination area and the clean area, and it's a safe distance away from any potential airborne radiological contamination. When the waste reaches the transition line, the waste is transferred from the push-pull device on the clean side to a push-pull device in the contaminated area, and then it's driven to the waste face. At the waste face, the containers are pushed off the spatula, the push-pull device, onto the disposal room floor. Our waste is stacked the equivalent of 3 55-gallon drums high, and it's placed in a honeycomb pattern on the floor to minimize any empty space. The location of each drum is then documented. And it's important to note that waste at WIPP is emplaced forever. It's not stored for later retrieval. WIPP is a permanent solution to the nation's transuranic waste disposal problem. This is our 41-ton forklift. It's what we use to move our remote-handled waste. Remote-handled waste gives off more radiation than contact-handled waste. CH waste, or contact handled waste, can give up to 200 millirem per hour at the surface of the container, whereas RH, or remote handled waste, can give up to 1,000 rem per hour at the surface of the container. To keep our waste handlers safe, remote handled waste is handled by robotic machinery, or it's packed in specially lined drums called overpacks. Prior to the events of 2014, RH waste was removed from the transportation cask, the RH-72B, and it was loaded into a large piston-like unit called the facility cask. The facility cask was then downloaded into the mine with the waste loaded on it, where the 41-ton forklift carried it to the disposal room. Because it's so large, the 41-ton forklift had to be disassembled and brought into the mine in 5 trips, and then reassembled 2,150 feet underground. Once in the disposal room, the piston device on the facility cask pushed the RH waste into boreholes drilled into the side of the disposal room walls. Once the RH waste was emplaced, a 6-foot concrete and steel plug was inserted into the borehole, isolating the RH waste from the rest of the mine. Now, only 4% of the true waste designated for WIPP in the complex is designated as remote handled waste. During mining, mined salt is brought to the surface on the salt hoist 4 cubic yards at a time. It's then dumped into the surface salt haul trucks. The trucks can hold 20 cubic yards of salt per trip. Now, once the truck is loaded, it takes the salt to the north end of the site, where it deposits the load in one of our large salt piles. This is the salt hoist. The salt hoist was the first shaft sunk at WIPP. Once the shaft reached a depth of 2,150 feet, a continuous miner was lowered into the underground, and a drift was then mined over the air intake shaft. The head frame, the cage, and the motor were first used in 1926, and they were actually brought to WIPP from another mine. 15 miners can ride on the salt cage at any given time. The cage has 2 levels. The top level holds 9 miners, and the bottom level holds 6. Now, when we say it holds 9 miners, that doesn't mean there's room to walk around. You're standing shoulder to shoulder, front to back. It's a tight squeeze. Now, like most traditional mine hoists, the salt is loud and it bangs around as it rattles along its wooden guides. It's a much different ride than the waste hoist, which is so smooth that you can almost forget that you're moving. The trip on the salt hoist takes about 3.5 minutes. The waste building is a steel and concrete structure that's designed to withstand a Category 4 tornado. Unlike most traditional mine hoists, the waste hoist is housed inside the waste building. But this is a safety feature in the event that there's a radiological release during downloading. The release would be confined to the waste hoist building, which is also HEPA filtered and under negative air pressure. The waste hoist can hold 75 people on one level. There's a personnel and materials level, and then there's the waste level below that. People and materials can ride together on different levels, but waste always travels alone on the lower level of the conveyance. The lamp room is a control point for entry into the mine. All miners stop by the lamp room to pick up a mine radio, headlamp, hard hat, miner's belt, a self-contained self-rescuer, safety glasses, and miner's brass before entering the mine. The mine brass has been used as a form of accountability in mining since the 1600s. By looking at the accountability board, an attendant can see who's in the mine at any given time. Radios that the miners carry also serve as a tracking device that shows where a miner is in the underground at any given time. In the lamp room attendant maintains an updated version of the mine. As miners brass in or brass out, they can see the areas of the mine that are going to be inaccessible that day due to mining, emplacement activities, or ground control. This helps crews plan their trip into the mine, as well as noting potential hazards that they may encounter while they're in the underground. The brass accountability board is the oldest method used at WIPP for keeping track of who's in the mine. After donning your PPE or personal protective equipment, you sign into the accountability book and are assigned a numbered brass tag that you'll carry with you at all times while you're in the underground. In the event of an emergency, miners brass out by turning their brass tags into the mine room attendant. If brass number 16, for instance, is not on the board, the attendant can see who was assigned that brass and attempt to contact them using the radio system. On a more macabre note, brass is used as an accountability tag because in the event of a mine fire, brass doesn't burn, but we do, and the brass can be used to identify any fatalities.
Ready, sir.
The trip into the mine on the salt hoist is an experience. A lot of visitors liken it to a carnival ride. It's loud and it's bumpy and it seems to move really fast. In reality, you're only going to be moving about 7 miles per hour or about 614 feet per second. Just like ascending half a mile into the air on an airplane, your ears are going to pop as you descend the equivalent of 1.6 Empire State Buildings. There's no light on the cage, so if you've forgotten your miner's lamp, you wouldn't be able to see your hand in front of your face. The trip takes about 3.5 minutes, but we're going to speed it up for you today during today's virtual tour. Welcome to the WIPP Underground. Arriving 2,150 feet below the surface of the desert, the bottom lander, or the salt station attendant, will open the cage and let you out. This is the oldest section of the mine. It was what was first mined back in the 1980s. The salt station is the center point in the mine from which all other points are measured. So as you step off the conveyance, you're standing at North 0, East 0, West 0, and South 0. Each intersection in the underground is marked in relation to this point. Notice the heads-up display in the upper left of the screen. It'll keep you updated by showing you the number of feet you are from the salt shaft. On the north side of the salt hoist is the grizzly. As the salt haul trucks bring mined salt into the salt station, they dump it onto a large metal grate and it falls into a storage bin. As salt is brought to the surface, a door at the bottom is opened, allowing 4 cubic yards of salt into the hopper, which is attached to the bottom of the salt cage. If you're unlucky enough to be on the cage as a truck dumps a load of salt, expect to be covered in a very fine layer of salt dust. Now remember that all of the dirt that you see around you today is actually the same substance that you use to season your French fries. We're standing in the middle of a salt bin. We're here at the Underground Facility Services offices. The Underground Facility Services monitors overall operations in the WIPP Underground. They keep the equipment and services working in the underground, and they're the people that you call if you need access to an area that's restricted. UFS, or Underground Facility Services, has fully functional offices in the underground. They've got computers and printers, conference area, even air conditioning. When we need a cart for a tour, we call UFS. When we're going to take a tour into the mining area, we call UFS. If a bulkhead door is not working properly, who are you going to call? Underground Facility Services. Bulkhead doors help isolate areas in the underground. Double sets of interlocking doors create an airlock that prevents air from moving between areas, which allow us to create air circuits. Bulkhead doors allow us to move air to where crews are working in the underground. Now, air is a valuable commodity in the underground because airflow moves diesel exhaust and particulates away from work areas, keeping our people safe. The doors are pneumatic and they're activated by pulling the red or green ropes that are located in front of the doors. They're built so that only one set of doors can be opened at a time. So if you look through the window and see the other doors open, you're going to have to wait before your door will be allowed to open. Miners work their entire shift in the underground. They could head underground on a sunny winter morning and come up to a layer of snow 10 hours later. While in the underground, they have a place to eat their lunch in the underground assembly area. The area is equipped with tables, microwaves, a refrigerator, hand washing stations, and computers that are equipped with internet access. Metal coverings over the tables allow miners to remove their hard hats while they eat, something that you can't do anywhere else in the mine. When you're 2,150 feet underground, it's really inconvenient to have to haul things out of the mine when they need maintenance or repairs. Often equipment is too large to fit onto the hoist in one piece. Bulkhead doors or the salt haul trucks, or even steps and stairs. The underground welding shop is a fully equipped welding shop where crews build things that are needed in the underground. Bulkhead doors are a prime example. The large doors won't fit onto the hoist, so sheets of metal are downloaded and assembled in the welding shop and then transported to the install site. In the underground, miners use a large cutting machine called a continuous miner to carve drifts or hallways and large disposal rooms in the underground. The continuous miner is operated remotely and moves forwards on tank treads. The cutting head is a large cylinder with numerous teeth that moves up and down across the face of the salt. The mined salt falls to the floor where gathering arms scoop up the salt onto a conveyor belt that delivers it to the back of the continuous mining machine. The conveyor dumps the salt into a salt haul truck but then takes it to the salt hoist for removal or for use in the mine leveling the floor. The continuous miner can mine roughly 8 tons of salt per minute. That's 118 cubic feet or 4.3 cubic yards of salt per minute. Airflow in the underground is important because it removes dust and exhaust particulates from the work area. Prior to 2014, WIPP circulated 440,000 cubic feet per minute of air throughout the mine. Miners often wore a light jacket in the underground because the air was so cold. Now, when we switched over to HEPA filtration mode in 2014, the volume of air dropped significantly to 65,000 cubic feet per minute. Since then, we've installed the interim ventilation system, or the IVS, which has increased our airflow to as much as 175,000 cubic feet per minute of air. But the new SSCVS, or Safety Significant Confinement Ventilation System, will increase our airflow to as much as 540,000 cubic feet per minute of HEPA filtered air. An interesting note about HEPA filters, they were first called the Absolute Filter and were designed in the 1940s as part of the Manhattan Project, specifically with radiological particles in mind. Salt is the ideal medium for the disposal of true waste because it's anhydrous and it's plastic, meaning that when you open a hole in it, the salt wants to fill in that hole through a process called salt creep. Salt creep is great because it'll eventually encapsulate the waste in the underground at 2,000 pounds per square inch of pressure. And we want to slow that movement until we leave an area, and that's done through a process called ground control. Crews are constantly measuring points in the mine to see how fast that salt is moving. Roof bolts, straps, and cables are installed in the ribs and the back to slow the movement of salt. Eventually, however, the salt will break the bolts and more bolts need to be installed or the area has to be abandoned. Bolting is the primary ground control activity in the underground. Crews use a bolting machine to drill a 4-inch hole into the ribs of the back. Then they install a 14-foot long, 7/8-inch diameter steel alloy bolt into the hole. bolt's attached to the wall using an epoxy mixture that holds the bolt in place. The epoxy tube is inserted into the hole, and then the bolt is spun up behind it, mixing the epoxy, which sets in a matter of seconds. A metal plate and a holding cable are bolted to the bottom end to hold the weight of the salt. That cable is designed to stop the bolt from falling if the bolt breaks. Now, roof bolts can hold up to 45,000 pounds of pressure, which is either pulling the bolt as the salt delaminates or horizontally as the salt moves across itself up in the back. Roof bolts can hold up to 45,000 pounds of pressure, which is either pulling the bolt vertically or pushing side to side on the bolt as the salt layers slide across each other. When a roof bolt breaks, it sounds like a rifle going off and everybody ducks. We lose about 44 bolts in the mine every week, and so our crews are constantly removing the old ones and installing new ones. Magnesium oxide is an engineered barrier that's designed to keep the radiological particles in the repository in the unlikely event that the mine were to fill with water. MgO, or magnesium oxide, would raise the pH level of the water to a point that radiological particles become insoluble. It also acts as an absorbent. The MgO sits on the top of the waste stack in the disposal rooms in a polyethylene bag. In the event of a fire, the magnesium oxide will smother the waste drums, helping to put out the fire. Due to the plastic nature of salt, the ground control activities consume a large volume of time and energy in the underground. To reduce the need to maintain parts of the mine that are no longer used, it was decided that the south end of the mine would be permanently closed off. 150 feet south of 2520, steel bulkheads were installed in all 4 of the north-south drifts. Then the drift was filled with 150 feet of mine salt, and a second set of steel bulkhead doors were installed at the 2520 intersection. This significantly reduced the number of man-hours needed to maintain the ground control in the south end of the mine. Just a quick stop here to show you our underground ambulance station. So an ambulance and a WIPP firefighter are stationed in the underground anytime that we have personnel in the mine. The firefighter is only in the underground to assist with medical issues. He's not there to fight fires. The WIPP response to an underground fire is to evacuate the mine. Miners are allowed to fight an incipient or beginning stage fire, but we're not required to. We work hard to keep the amount of combustible and flammable material in the underground to a minimum. You may remember this place from the waste emplacement portion of the video. The waste station is at the bottom of the waste shaft and is the primary conveyance of materials into the mine. It's also the only way to get waste into the mine. The waste cage has 2 levels, the personnel level, which can hold up to 75 people, and the waste level, which sits below the personnel deck, although waste always travels alone. The waste hoist is unique in mining, as it's guided by 4 cables instead of rigid wooden rails. This makes the trip into the mine much smoother, as the cables actually push and pull the cage, keeping it aligned, rather than bouncing around on wooden rails. There are also 6 cables that lower the cage into the mine. This is a safety significant feature in that each one can support the fully loaded 45-ton cage. The hoist also has a 45-ton counterweight to reduce wear and tear on the motor. The counterweight also allows the cage to be brought to the surface without power in the event that the site loses power, backup power, and redundant backup power. In other words, at WIPP, safety matters. Anything that you need in the underground needs to be brought into the underground, and that goes for power as well as equipment. WIPP brings electricity from the surface at 12,800 volts. Electrical substations are placed throughout the underground where crews can reduce the voltage down to the level that the tool they're using requires. For example, the continuous miner runs off of 880 volts. while computers, coffee machines, and lighting systems are the standard 110. Like the welding shop, the fully equipped underground maintenance shop allows mechanics to perform scheduled maintenance, repairs, or even a full overhaul on a tour cart or the 41-ton forklift without transporting it to the surface. Because of the high salt content and the low humidity in the underground, if you bring a vehicle from the underground to the surface, the wiring is going to begin to crack, and within a few days that cart will never run again. Now, because the risk of a fire is greater in the maintenance shop, an automatic fire suppression system has been installed in the maintenance shop that will blanket either a specific area or the entire shop with a dry powder fire suppression system if a fire is detected, keeping our workers safe. Now, when you think of mining, you might think of a guy with a lantern who's going into a rickety wooden mine shaft with a caged canary. But at WIPP, underground operations involve a lot of sophisticated equipment, coordination, and communication. To keep things running in the underground, miners have to have access to fully outfitted offices with computers, phones, printers, water coolers, even cubicle walls. So the only difference is that you're going to need to keep your hard hat on during the conference call. So this is the final stop on our tour today. I hope you've enjoyed it. This area is the experimental area, or EXO. Universities from around the nation use the WIPP repository for their experiments due to the low levels of background radiation. Now, that may seem counterintuitive that you would go to a nuclear waste repository to find low background radiation, but because we're in a salt bed and we're 2,150 feet underground, you actually find very, very low levels of background radiation. Some of the experiments that we've had done here are the search for dark matter using a particle accelerator to search for energy or matter that seems to go missing. Another one is nematodes, looking at how much radiation is good for life. And what they found in a low background radiation environment, that they don't thrive. The theory is that possibly the amount of radiation that we receive from the sun and from our natural environment boosts our immune system. We've had studies on how plants handle low and high levels of radiation and how salt reacts to high temperatures. So I wanted to thank you for joining us today, and I hope that you've learned a lot on this virtual tour. On behalf of all of us at Nuclear Waste Partnership and the Waste Isolation Pilot Plant, we'd like to say thank you for coming. You'll please watch your hands, your feet, your arms, and legs as you exit the conference call. Thanks, and have a great day.